All right, so that's the half portion of this course, which is on the diodes. First three chapters are pretty much on the diodes. The next three chapters for this course covers is on uh, transistors. Transistors are also type of semiconductors, but one specific transistor type that we will be talking throughout these three chapters, actually chapter 4, 5, 6, even part of chapter 7. But of course, chapter 7 will be your next course. Uh, one specific type of transistor we will be looking at is called as BJT, stands for Bipolar Junction Transistor. Yeah, to know why it is bipolar, you may need to wait for some time. So, so, so there are various types of transistors. BJT is a very basic type of transistor. In fact, this is the very first transistor that got invented. But the later advances in the transistor industry follows the very basic principle of how the BJT operates. So, principle behind the operation of transistor is same irrespective of whether you're talking about BJT or whether you're talking about, there is another type of transistor called as FET, and an extension of FET is called as MOSFET. An extension of MOSFET is called as CMOSFET, but it is usually go by the name just CMOS. So FET is called as, so it's a field effect transistor. MOSFET is, so this is a metal oxide semiconductor. So metal oxide semiconductor, and it's a FET2, it's a field effect transistor. So it's a metal oxide semiconductor field effect transistor, or a MOSFET in short. It's heavily used for high power applications and high speed applications. CMOS is an advancement of MOSFET. That C stands for complementary MOSFET. Again, there are variations under each one of them. FET has two different types of FETs. MOSFET has two different types of MOSFETs, and so on and so forth. But the operation of transistor itself, it's same as how pretty much BJT operates. Again, the advancements goes in terms of speed of how fast the transistor is operating, in terms of efficiency, meaning that loss of power. So that's what efficiency. If the transistor is highly efficient, meaning that there is not much power that the transistor is actually wasting when you're controlling something. Yeah, so the advancements I'm saying, like when you go down the line, some of these operates at very high power, and some of them very low power, and some of these you can damage it by simply touching them. Their power, yeah, the heat dissipation. Some of these transistors are very sensitive. That means they are prone to electrostatic field, meaning that you can damage it by simply touching the pins of it. That's heavily used the design of computers like that. But one of such IC you will see down the line, especially in a communication course. Uh, and I think the current technology of transistor is usually called as a FinFET. I think it's invented by Intel. It's a three-dimensional transistor. It's a 3D transistor. It's like fins of a the appearance of this transistor. It looks like a fins of the shark. So that's why the name FinFET. But again, yeah, it's based on doping, but controlled. Yeah, controlled doping. Yeah, it's not a visually you can't really tell because all these transistors are nanometers in their size. So you can't really see any of it. You're probably going to see a piece something like this with like billion transistors on it. So it's not visible to directly see without the use of equipment to actually see how the size of the transistor is. So extremely complex, very high in number in terms of the number of transistors. And usually the Texas Instrument, Intel, AMD, all these are manufacturers for these types of processors. But our topic for this course is on introducing the transistors. Specifically, we will be looking at the BJTs. On the formula sheet is the back page of it. The second page of that formula sheet belongs to the transistors. So all the formulas in there are in relation to the transistors. So what can I do with the transistors? We will talk about that, and then how the transistor operates, we will talk about later. So there are only two applications that you can use this transistor. Transistor can do two things. You can use it as an amplifier. So it can amplify electrical signal. Transistor can be used as an amplifier. So what it can amplify? It can amplify the voltage. It can amplify the current. It can also amplify the, what is P for? Power. So depending upon what amplifier, we can say voltage amplifier, current amplifier, power amplifier. And another application is, it is going to be used as an electronic switch. Meaning that you can turn on and off, because that's what a switch is, correct? It is used to turn something on and off. So that's the behavior. So you can turn the load on and off using an electrical signal. For example, if you think about a switch, we always think like a manual switch, right? You turn it on, turn it off. But this one is not a manual switch. You can control that switching action using an electrical signal. That means another circuit can actually control another circuit without any manual intervention, like your AC and heater turns on and off automatically without manual intervention, right? So, and there are a lot of applications, of course, to these. But the behavior is, it can be either used as an amplifier or it can be used as an electronic switch, just like on and off. How many terminals a transistor consists of? It has 3 terminals, unlike a diode. Diode has only 2. But transistor is 3 terminals, and there are range of transistors. Some of those I mentioned before. Some of these you will see in various courses such as UJT, Junction transistor. So, but some high power transistors you will see down the line. The transistors that are used in the ovens, in the refrigerator, some high power applications. And any application that you see, it involves transistors, diodes, pretty much. So it's a building block of any electronic instrument that you will see. Uh, so how can a transistor is going to be formed? So we know what a diode is. So if you take a diode, remember the diode has two terminals, correct, anode and cathode. But how many junctions a diode has? Diode has only one junction. Let's say this junction is J1. But what a transistor is, let's say you extend this junction on this side. Let's say you dope this with N-type material. Now you're going to have another junction, correct? So that's an NPN type of BJT. Again, what NPN, what it does, that's not yet. It's an N-type semiconductor. So if you add an N-type semiconductor onto the left of this P-type, then what you will form is another junction, and the type of transistor you will be forming is an NPN type of transistor. Again, N means it has lots of electrons, extremely small holes. Right? If you take the same diode, for example, same PN junction, where you have a single junction, but on this time, if you extend one more layer onto the right side of the N-type and dope with P-type semiconductor, then you will form another junction too. The type of transistor you will be forming is called as PNP. So there are two different types of BJTs that are available. One is called as an NPN. Another one is called as a PNP. It's an extension of one more layer of semiconductor. If you put N-type before P, that would be NPN. If you put P-type after N, that's a PNP type of transistor. Throughout this course, you will see an NPN transistor. Even down the line, the PNP operates exactly in the same way as an NPN, except the biasing will be opposite. Meaning that if you provide positive voltage somehow to an NPN, PNP requires a negative voltage to operate. Direction of currents will be opposite since you are changing the polarity of the signal source. But other than that, the basic principle behind the operating conditions of these two is exactly identical. But throughout this course, you will see an NPN. Here and there, we will touch PNP. But in the next course, you will see use of PNP as well. Combination of NPN and PNP is also heavily used. One good example is the CMOS. Remember the CMOS I mentioned before? Complementary. Complementary means opposite. That's what complementary means. Opposite to one. Like if you have positive, it's complementary is negative. So CMOS, which is complementary MOSFET, is a combination of PNP and NPN. So one CMOS requires actually two transistors. That's why the complexity of CMOS is usually higher than traditional transistors. So in the place of one transistor, if you're using CMOS, you need two transistors. Anyway, opposite in their polarities. Later on, when you get into digital courses like digital circuits, you will see this complementary term again, but in a sense of complementary of 1 is 0, complementary of 0 is 1. So that's another sense of, in the digital circuits perspective, complementary is either 1 to 0 or 0 to 1. So this is simply implying that the signal is inverted. That's pretty much what it means. So these are the symbols you see for a transistor. What do you see the difference? So if you closely pay attention, you see this arrow right here inside the transistor, inside that circle. There is a small arrow that is pointing outside, as if current is leaving. If you see that arrow pointing out, that is an NPN transistor. If you see the same arrow pointing in, that means it is a PNP transistor. So all you do is, it's a three terminals just like this. It's up to you whether you put a circle or not. It doesn't really matter. So this is the transistor. If you see arrow pointing out, that means it's an NPN type of transistor. Current is leaving. So this tells you whatever this terminal is, the current is leaving the terminal for NPN. For PNP, the current is entering for the same terminal. So now, why this transistor is called as bipolar? Bi means two, polar means polarities. So the current in the transistor is because of both holes and the electrons. The current given within the transistor is because of both electrons and holes. That's why the name bipolar. Sometimes you might think, okay, transistor has how many junctions? How many junctions? Junctions is only 2. That's not why it's called as a bipolar. Are we clear? Bipolar means it's 2 polarities. Current contribution is from holes as well as from the electrons. That's why the term bipolar. It's a current controlled device. So we will talk about specifically what does that mean. Transistor controls the current. NPN or PNP. So let me give you the terminal names of, remember for diode we call as anode and cathode, correct? So let's say I have this transistor. So what type is it? So since this arrow is leaving, that transistor is a, so wherever you see an arrow, the terminal name is called as emitter, which is usually indicated by E, and the name is called as emitter. Opposite to the emitter is indicated as C, and it's called as collector. And this terminal right here is called as base. So these are the terminal names of a transistor. You have emitter, base, collector. So it will be the same. So if you take, so this is for NPN. So which one is in N here? Since we are saying NPN, this is N, this is P type, this is the N type semiconductor. Again, remember that N type is very rich in the electrons. P type is very rich in the holes. So the doping method on the collector is N type. The doping method on the emitter is also N type. But the doping method on the base is a P type. So that's for an NPN transistor. Yeah, you can do that. So if you see an arrow pointing inwards like this, again the terminal names are wherever you see an arrow, that is a emitter. The opposite is the collector, and this one is the base. But the doping method used in PNP would be, the collector would be, so the collector would be the positive or P type. So it's a PNP since the arrow is pointing inside. But wherever you see arrow, that's the emitter. So collector is a P type, base is a N type, emitter is also a P type semiconductor in its doping. So its doping levels will be like that. As you can see, each lead is exactly opposite in its doping method, type of doping compared to NPN versus PNP. Right? So that's specifically implying basically, so if you have an NPN transistor like this, so this is emitter, base, and the collector, where you are forming how many junctions? Two junctions. One junction is between emitter and the base. Another junction is between base and the collector. So a transistor is two junctions and a three-terminal device. One junction is formed between base and emitter, or emitter and base. That's one PN junction. And you have another PN junction that is between base and collector, which is the J2. Same thing for the PNP as well. Two junctions. One is between base and emitter. Another one is between base and collector. Okay, we haven't talked about the operation of transistor yet. So this is just to show what each layer implying what terminal of transistor. So So this figure right here indicating the same, the junctions especially happening between base and emitter, you have one junction, and base and collector, you have another junction. So the naming of this transistor is also not, it also means something as well. So the collector, the purpose of collector side is to collect the electrons. The purpose of the emitter side is to emit the electrons. The purpose of base is just a medium to transfer these electrons from either collector to the emitter or emitter to the collector. So the basic idea behind a transistor is you require a base signal. Okay, that's the first thing is you require a base signal. Let's say you apply the base signal. The current will be controlled between collector to the emitter or emitter to the collector. That's how a transistor works. So the current conduction will be happening, the main current conduction will be happening between either collector to the emitter or emitter to the collector. But who controls it? The base controls it. If you think about a faucet, that's exactly what a transistor is. The knob you are turning is the base. Correct? If you completely turned off the faucet, obviously there are no flow, correct? So the flow of water depicts the flow of electrons. The faucet knob depicts the base itself. So if the faucet is off, if there is no base at all, there is no flow of electrons. So if you observe the direction of an arrow right here, why this arrow on the NPN is pointing outside? This is the actual path of the current from collector to the emitter. And for the PNP, the current direction will be like that. That's why the arrows were pointed accordingly. So for emitter, the current is leaving for an NPN. For PNP, for emitter, the current is entering from the emitter. But let's take a look at how this operates under the influence of the voltages. Again, base is a must signal applied in order to even have a current.